So we are ready now to move on to the inside of the foldable. So let's take a look over here, and we want to look at finding the inverse algebraically. I'm not going to read through all of these steps right now. There is one thing that I want to point out though on number 4. I just want to put a little note that we will need to look at restricting the domain or range anytime that the function isn't linear. So we'll talk about that as we get to it, but I just want to make that note there so that it's there for you as you go through additional problems later. So the first thing that we want to do is determine if the inverse is a function, and then we want to find that inverse. So I've drawn my horizontal line here. I'm going to use that for my horizontal line test here in a minute, but I guess I need to plot my function if I'm going to determine if the inverse is a function. So let's go to Desmos. And here is my function. Notice that I've plotted that dashed line at y equals x, and then I have my function f of x is equal to 3x minus 1. I have a point at 0, negative 1, and it looks like I also have a point at 2, 5. So I'm going to plot those and use those to plot my line. So 0, negative 1 and 2, 5, and I can plot my line. All right, so let's do horizontal line test. I'm going to use this purple line that I've drawn here. You're going to use your pen or pencil. And as I run this across, I see no places where I have more than one crossing point, so I'm good. My inverse is a function. So let's just go ahead and make ourselves a note of that the inverse is a function. So solving involves, again, the 5 steps. We're going to go through them one by one. So the first thing that we need to do is change f of x to be y. Sometimes y will already be there, but most of the time it's written in function notation. The second thing is switch the x and the y variables. We've got to swap those out. So everywhere I see x, I'm going to put y and vice versa. So x is equal to 3y minus 1. And now this just becomes a algebra problem just like any other problem that you've solved since middle school. I need to, let's go ahead and make a couple notes here. This is step 1, this is step 2, and now I'm about to do step 3. That way we can keep those in order and keep track. So if I solve for y, I'm going to have plus 1 on both sides, and that gives me these cancel, and I have x plus 1 is equal to 3y, and then divide by 3 to end up with x plus 1 over 3 is equal to y. All right, so we have solved. Number 4, restricting the domain and range. Well, we do have a linear function, so number 4 is not applicable. All right, we can take that function and go ahead and rewrite it in function notation if we want to, that inverse function. So we would say f inverse of x is equal to x plus 1 over 3. So now that we have our inverse, let's go ahead and plot that inverse. So let's look at Desmos. And I've called this function g of x just to make a distinction from f of x. And I'm going to say that it's x plus 1 over 3. And you can see that it is an exact mirror image, so we did do our math right. And I'm going to pick some points here. I'll have the point negative 1, 0 and 5, 2. So if we go back over here, I have negative 1, 0, and I have 5, 2, and I can draw my graph. And that's what my lines look like. So this was step number 5, plotting the graph.